This is a quick illustration of Charles' law. Charles' law is the relationship between volume and temperature of a gas. We're going to keep the pressure constant, and we're going to keep the number of moles constant. As you see here, we have our classic illustration of piston and cylinder, where we entrap a certain volume of gas at a given pressure. In this particular diagram, we're going to now add heat to it with some fire or whatever you want to do to heat the temperature up. And then, as you can see, as the molecules become hotter, they have more force, they travel quicker, they lift the piston up to a much bigger volume. And so this illustrates the fact that when you increase temperature, you increase the volume. And then if you allow it to cool, take away the heat and allow the gas to cool, the gas will now fall back to a smaller volume as you go to a smaller temperature. So temperature and volume are directly proportional. You increase one, you increase the other. And if you want them to be directly proportional exactly, you got to use absolute temperature. So you use the Kelvin temperature. If you double the Kelvin temperature, you will double the volume. And this little illustration here shows you the volumes going up by twice and going down by half as the temperature does the same.
The next thing we're going to learn about is the gas laws. There are 3 of them, and the first one is called Boyle's Law. Now, we are the gas particles, and we're inside a box. Just a regular box, but we're a very, very special gas. We're called an ideal gas. Whee! Listen, boys, we're an ideal gas. Way! But what does that mean? Well, because we're an ideal gas, that means we have to follow special rules. The first rule of Ideal Gas Club is there are lots and lots and lots of particles. The second rule of Gas Club is that when we're bouncing off each other, these collisions are perfectly elastic. Can you remember what that means? It means that there's no energy lost in the collision. The third rule of Gas Club is that when we're bouncing around, the only time we interact with each other is when we hit off each other. There are no forces between us. And the last thing about us, the last law of Gas Club, is that we're very, very small. That means that the box is mostly filled with space. So that's the rules for being in an ideal gas. Whee! Now, the first gas law we're going to learn about is Boyle's Law, or as the French call it, Le Mariotte Law, or something like that. Boyle's Law concerns the gas particles in a box. And I want you to think about us bouncing off the walls and bouncing off each other. But we're going to change something. Okay? We're going to change the volume of the container. The temperature is not going to change. That's absolutely certain. The temperature is not going to change. We're going to keep it the same. But we're going to change the volume. Now, you can see it's bouncing around. What do you think will happen if the volume of this container is cut in half? Have a guess. If you guessed that when they cut the volume of the container in half, that the number of collisions doubled, you'd be right. Whee! That's what happens. Look, regular size container, we're bouncing off like this. B, ooh, E, ah. But when you cut the container in 2, look, ooh, E, ooh, E, ooh. It's such a laugh. So as you can see, the pressure and the volume are inversely proportional to each other. When you double one, the other one...
We're now going to study Avogadro's law. Avogadro's law is simply the relationship of the number of moles of gas being proportional to the volume in which they occupy. Once again, we've got our piston and cylinder picture, but this time it's a little different. We have a side on it where we can pump in more gas or remove gas. We are going to keep the pressure and the temperature exactly the same during this, and that is one of the criteria for Avogadro's law. As you can see from this illustration, we have a certain number of particles floating around inside this system, If we pump in more gas, and you could do this like with a bicycle pump, as you put in more moles of gas, the volume is going to increase proportional to that number of moles. So it's very simple. Whatever your volume is with 1 mole, your volume will be double that with 2 moles, and it'll be triple that with 3 moles. That is Avogadro's law, the direct proportionality of volume and number of moles. And as you can see here, we have a simple equation to help remind you of that. Volume over moles in one state equals volume over moles in the other.